Okay, we're in business. Hi, everyone. My name is BB Renson, and I will be presenting on the spatial temporal variability of foraminifera off the coast of San Diego. So a quick introduction, foraminifera are protists with tests made mostly of calcium carbonate and organic material. And so they're very useful bioindicators of past climates, not only because they're highly sensitive to the changes in their environment, but also because, especially when they have a calcium carbonate test, they can really preserve as fossils in the sediment, allowing us to analyze them. And so we know that water depth can affect pressure, temperature, and dissolved oxygen, but this actually affects the zonation of benthic foraminifera and their preference for environment. And now with climate change, we see an increase in ocean temperatures, which decreases dissolved oxygen, altering this zonation. And because my research is being conducted on the CCB, it's important to understand this is an area of high nutrient input and high productability. And so my research really wants to characterize the foraminiferal assemblages on these shallow shelves on the CCB and examine their variability compared to water depth and dissolved oxygen over time, and maybe even see if there are changes related to ENSO. Some of the methods, so as you see on these in this top row, it's the research is done on the CCB with annual research cruises being deployed in the summer between 2001 to 2011 to 3 various stations, 100, 200, and 300 meters depth. The sediment was retrieved using a multicorer, and the top 1 centimeter was sliced off for foraminiferal analysis in the lab, and water depth and dissolved oxygen was also measured using CTD equipment as well as an oxygen probe. Back in the lab, the sediment samples were split using a multicorer and sieved and picked for foraminifera, which we then split into 2 various size fractions. We also counted at least 300 specimens per station to ensure that we have a good representation of the community composition in that area. And then a Spearman rank correlation coefficient was used to find the analysis between these environmental parameters and foraminifera abundance. And so here we see the total relative abundance of both benthic and planktonic foraminifera over all stations in all years. So on the left, there are 4 most common planktonic benthic foraminifera are Cibicidoides, Globo-cassidulina, Bolivina, and Bulimina. And for planktonic, we only saw Orbulina and Globigerinoides at our samples. Now we're looking at the relative abundance of those top 4 benthic foraminifera, as well as the planktonic Orbulina in the dashed line. We don't really have that much research or data for the 2000 or the 100 meter station. So we're mostly looking at these bottom 2, but we can really see that there is kind of a stable community composition over all the years, with Cibicidoides being relatively in high abundance in the 200 meter stations, and Globo-cassidulina and Bolivina being really in high relative abundance in that 300 meter station. However, we do see a shift in 2010 with a spike in Cibicidoides relative abundance and a decrease in Globo-cassidulina and Bolivina abundance. Now we're looking at the correlation analysis between percent Bulimina and dissolved oxygen on the left and water depth and Globo-cassidulina on the right. As we can tell by the p-value and the Spearman rho value on the bottom, these are significant. And so on the left, we see that 43% of the change seen in relative abundance of Bulimina can be attributed to dissolved oxygen changes, and 44% on the right of percent Globo-cassidulina changes can be attributed to depth changes as well. And so other results we found was that the relative abundance of Bulimina also decreases significantly with water depth, and that mean dissolved oxygen decreases with depth, which is obviously expected. But however, we found no secular change in the planktonic foraminifera related to ENSO. And so a potential explanation for the 2010 shift, an increase in Cibicidoides in the 300 meter station, can be potentially due to upper sediment mixing that makes it more like the 200 meter station. We also looked at past research and found that Cibicidoides is usually more abundant with depth or in an oxic sediment. However, we found it in higher abundance in the more oxic 200 meter station, and Globo-cassidulina and Bolivina in the more hypoxic 300 meter station, which is also seen in past research. Bulimina was really seen in low quantities at all stations. So my research helped to kind of further understand the relationship between these assemblages and past as well as future environments. And there's actually someone in Dr. Gray's lab right now looking to further my research, looking at the 2011 to 2018 years, so that we kind of have a long-term analysis of these research foraminifera, these foraminiferal assemblages. Yeah. All right. Well, so thank you so much for listening. That's my presentation, and I can take any questions if you guys have any. Thank you.